Hello, my name is Safina Ali, and along with my collaborators Prerna Ravi, Kate Moore, Hal Abelsil, and Cynthia Brazil, we are presenting our work, A Picture is Worth 1,000 Words, where we co-design text-to-image generation learning materials for K-12 along with educators. Much like many emerging media, generative AI ushered an era of new creative possibilities for education, such as creating ideas, art, music, animation, code, getting personalized feedback, and support. One such tool was text to image generation, where generative AI algorithms are coupled with large language models trained on millions of text image pairing, and they learn to use natural language prompts, say a child dreaming of magical art, to generate corresponding images. But it also poses serious ethical implications such as inherent biases, inaccuracies, unethical use of data sets, deepfakes. For example, this is a generated image of a Barbie from South Sudan. And you can see here that the generated image is carrying a gun, which is a very biased representation. With the aim to help students and educators learn about text-to-image generation tools, we co-designed text-to-image generation learning materials for K-12 students with educators. We conducted teacher training professional development workshops for educators to learn about how these algorithms work, and we did this with the aim of empowering educators to develop learning materials for their students. Educators comprised of teachers and education researchers, and the training spanned across 2 workshops with a total of 30 educators. We had 6 main modules in our teacher training program. The first module included educators learning about what generative AI algorithms are and how they are different from other types of AI. Then they learn about what text-to-image generation algorithms are through exploring generated media. Finally, they explore some applications of generative AI in the classroom, such as creative learning, assessment, feedback, ideation, lesson content generation, etc. Here are some examples of generative AI. Here are some examples of text-to-image generation used to create compelling media. Then they looked at bias in visual generative algorithms. When asked about what they want their students to know about generative AI, certain themes emerged from educators. They wanted the students to know that generative AI is biased, the responses are not always correct, which tools they can use for free. They wanted students to know about data security, writing good prompts, and then how the models are trained. In Module 2, educators explored text-to-image generation algorithms using interactive tools. They created different kinds of media with these tools, such as telling visual stories, creating self-portraits, and constructing dreams. While creating self-portraits, limitations of these tools often came forward, such as different ethnic or gender-related biases. In the next activity, they reflected on the creative process and product of working with these tools. Here's a self-portrait created by a participant in Workshop 1 using Midjourney. In Module 3, they learned about the technical understanding of how these algorithms work. They learned about dataset used to train text-to-image generation algorithms, how diffusion models work, how large language models work, and together how they can be leveraged to create a meaningful visual starting from a natural language prompt. We use visualizations to make this understanding clear to non-technical users. In Module 4, they learned about K-12 AI literacy. We first looked at the big 5 ideas in K-12 AI literacy regarding what children must know about artificial intelligence. Then they explored K-12 AI literacy tools and materials that exist already from previous research. In Module 5, educators designed learning activities for K-12 students. Here, they first identified stakeholders, so who their target audience was, how old they were, what their different learning needs were. Then they developed learning goals for their tool. Followed by this, they worked in groups to design and share prototypes. They first decided which learning method would be most appropriate for developing their tool. They decided how they will assess the efficacy of this learning material. And finally, they discussed the social implications of the tools that they are developing. we'll be presenting some rapid prototyping findings. We had 26 educators engaged in groups to design a total of 19 learning projects. Some educators worked independently and some educators worked in teams of 2 or 3. The target learners were a mix of ages. So 2 teams chose a mix of ages, 4 teams chose elementary school, 7 teams chose middle school, 7 teams chose high school, and then 1 team chose university students. The learning goals also varied. Educators chose creative writing using generative AI, auditing algorithms, communicating new AI models, identifying bias, ideation with AI, imaginative, creative design iteration, generative design, and geometric shapes. Educators chose topics that were most relevant to their teaching, so we could see them bringing their own teaching expertise into this activity. Educators also chose a bunch of different pedagogy tools such as games, structured activities, debate, curriculum, and interactive tools. 7 projects out of the 19 also address algorithmic bias within the learning goals that they identified, and they integrated those with AI learning. Rapid prototyping led to K-12 curriculum, teaching activities, assessments, game concepts, and interactive tools. Now we'll be giving some examples of what participants generated in these rapid prototyping workshops, which lasted for 2 hours. Here's an example of a game called Idioms that introduces text-to-image generation for K-12 students. It's a multiplayer game where players draw and text-to-image generator generates, another player draws, and the host tries to guess which is the AI-generated image. Here's another example called Expanded AI Ideation, which is a curriculum developed by a high school teacher that uses AI image generators to foster creativity in the design process. Another team of educators created a lesson plan called Moving Beyond Algorithmic Audit with Image Generation Tools, where they explore algorithmic audits versus evocative audits and which ones are better for students to learn about bias in AI tools. In the last modules, teachers discussed the future of generative AI tools in K-12 settings. This activity involved group discussions on creativity, ethics, and the future implications of K-12 learning. Through pre and post assessments, we learned that participants' self-reported levels of familiarity with generative AI increased. Overall, in this paper, we contribute learning goals for teaching educators about text-to-image generation algorithms. These can be extended to teaching other socio-technical AI systems. We developed learning materials to teach text-to-image generation algorithms to non-technical learners, which can be used for other professionals and K-12 students. We suggest a co-design approach with teachers, where they not only learn about a novel technology, but they create learning materials, tools, and curriculum around it for their students. We suggest ways to prepare teachers to design curriculum for their learners. Thank you. These are our contacts, and you can scan this QR code to gain access to our learning materials.